Okay, hello everyone and welcome to this webinar about Introduction to FEM-Design. My name is Markus Mitikka and I'm working in StruSoft Finland as a customer coach and support. First things first, this webinar is recorded and the recording will be sent to you after this webinar. And you can ask questions in the right side of the screen in the Go to Webinar tab. There's a question box. So I try to check the box every now and then and answer any questions you might have. Let's start about our software portfolio. These are the software currently we are providing. And first one is the Impact. It's a precast software for precast elements. You can manage your production and transport and all of this precast concrete stuff. And then we have the FEM-Design, which I'm going to show you today. And we have the Dimensions and Spacecast. These are the FEM calculation programs. And then we have the WinStatic, Yigi and Dimension, smaller structural designing software, and the pre-stress for pre-stressed concrete elements. You can design them with this. Then we have the WIP, beam energy and beam contact. Okay, a little bit about StruSoft. We have over 240 employees currently, and we have offices in 20 locations all over Europe and also in Philippines, India, and Australia. And the FEM-Design development is currently situated in Romania. And why would you choose FEM-Design? It's an intuitive and designer-focused software. It's a Nordic product which have a free local support service. And you can design concrete, timber, steel, CLT, composite, and masonry structures with this program. Also, you can do the reinforcement design with the concrete design module. We have the fire and dynamic analysis for concrete, timber, steel, CLT, and composite structures. Then we have the documentation module, which I'm going to show you also in this webinar. And these are the modules we have currently in the FEM-Design. So we have the 3D structure, which I'm going to show you today. It's the biggest and the best, has the most feature out of these, and 2D plate for designing one plate structure. Then we have the 3D frame for frame analysis. And these next are modules of the FEM-Design. So we have 3D soil foundation design and concrete steel design and steel joint design, timber design and CLT, masonry design, composite design. You can see all the available designing tabs here also. And then how you get started with the FEM-Design? Well, one option is to get started with IFC Import. So if you have an IFC model from other programs which you want to use in our software, you can import this. This is a IFC model and this is how it looks like in our program. And I'm going to show you this and how to fix the IFC model to FEM-Design and how it can be used most best. And then there's the other option. You can use the DVG or DXF import. So you can model the load-bearing structures or loads or whatever you want to model in the AutoCAD. Then you can import it to FEM-Design. And based on this, you can create a model like this. I will show you also this option. And let's go to the FEMDesign now and check how does it look like. So the first one, when you start the FEMDesign, is then you can choose the national annex here. These are the available right now. But I'm from Finland, so I will choose this Finnish national annex, like so. And this is the how does it look like when you just open it. And these are you have the edit, draw, modify tools, all these buttons you can find in the left side of the screen. So you can model a line or do this color scheme or anything. You can see all these 4 buttons you can see in this left side of the screen, and the view where you can change the view as settings or create your own views. You can say them in the right side of the screen. And this is the workflow which FEMDesign uses. So you go from the left side and all the tabs until you are in the designing modules. But first things first, you do the structure. We have the beam, columns, trusses, plates, and walls. And here you can make the supports, define the supports and covers if you need. And the next tab, you can create your loads, like load cases, and then the load combinations. And as for creating loads, you can do point loads, line loads, surface loads, temperature loads, and stresses, and support motion loads. And if you like to do dynamic loads, here is where you can transfer the loads into masses and define all the dynamic calculation settings. We also have these 2 macros, so wind load macro and snow load macro. It automatically generates the wind load or the snow load. Then we have a moving load, and you can export your existing loads into, let's say, Excel sheet and modify the load values there, and then you can import them to this model also. Then we have the finite element tab where you can change the mesh size and the division number for columns and beams. Then you have the analysis tab, but I will show you these much more in the next demo. And let's start about importing the IFC model. And you can do it by file open and search for the right folder there, and then you can check the files of type is IFC files. I have one here. Yeah. Then you can see if the IFC is in the correct place. Now it's in the 000 where it should be. And you can check the elements, IFC objects which are made to FEMDesign objects. If you see nothing here, then the IFC model is not working, but I have all these objects here, so it should be working. And the material, if you have some undefined materials, you can check for default material, or you can change your own here. You can select, let's say, concrete should be this, or you can change the default material here, like so. And then if there's some sections which are not found in FEMDesign, it automatically can create new. And let's do that. And if there's any errors or messages, it shows here. So it currently looks like this, and it's okay with IFC model. But if I turn off the physical view, you can see that the slabs are in different levels and the walls are not connected to each other. There's a little bit gap here, and there's these staircases or stairs are here. I will modify this by erasing these. These are not important for our model, so I just erase these. Oops. Like so. Now there's no extra slabs which the story definition can pick on. I will also delete these extra axes, and because they will be remade with the story definition. And that's the first thing I will do, is to create stories. And you can do them with this structure story command. And it says define and select horizontal objects. So I will change the tolerance to 0.5 meter and pick all the whole model. And now you can see I have created 1, 2, 3, 4 stories, and I can check them in this edit table. You can see the 4 stories here. So first thing which I want to do is align with this. There's these adjust analytical model tools, and these are used to fixing the IFC model into usable model. So let's start the adjust analytical model. And the first thing I want to do is align any objects to story. So I would like these slabs to be on this story level. So let's see, align any objects, and this is the tolerance, and I will choose these slabs. It says number of selected objects and number of modified objects. And now the slabs are in this same level as the story. I will show you. Okay, so this is one example, and now I will fix the whole model. And it says number of modified objects 109. And there you can see that this slab has 350 millimeter. So my tolerance of 250 millimeters is not enough. So I will change it to 0.5 meter. And now it says modified objects 1. And now it's in the same level. So by changing the tolerance, you can fix these issues. And the next thing I want to do is align any objects to axes. So let's say this wall has a gap to this wall, but I will want them to align it to the grid number 1. Let's see if it works. And now they're in the same. There's no gap here now. Let's see if, yeah. And I will do all of these whole model. And number of modified objects is 44. And now everything should be according to these axes. And next thing I want to do is fit any objects to stories. So for example, this top of this wall, I want it to be on this level 1175. So let's see if I put tolerance 0.5 meter and modified objects 2, and now the top of the wall is at the same level as this story I made. So, and maybe another one example is top level, and top and bottom of this wall should be in this level and this level. And let's see if it works. And yes, it does. So I will pick the whole model, and 237 was modified. Yeah. Now it looks pretty good, but let's go to the top level and see if we have any more mistakes here or something to correct. And you can see that this slab should be according to this wall. And this slab is not according to this wall. So adjust analytical model and let's fit any objects to axis. We have this axis B, and let's see if this edge of this slab is going to be according to this axis B. And yes, it works perfectly. I should create one more axis so I don't have this gap. So you can just copy these axes just with copy command. I will just make a few extra, which I forgot to do in the first place. So the correct modeling is based on these grids and story definitions. So now if we go to the story 4 and try to fix it again, now it align this slab to this grid number 11. Yeah, and let's go through the whole model. And you can see there's one more object which should be bigger tolerance, let's say of a meter. And now it is fit any objects to axis, and now it has done it. So I think this model is now fixed. We can see if it is okay to FEMDesign when we do the meshing. So I will generate the mesh and see if there's any issues. And there seems to be no issues. But I might want to delete these small areas like this, and like in this window here, like that. I want to delete them. They are not interested in this structure model. So we have this correct model, and you can see also if you have identical copies or overlaps, you can check them here. But what I wanted to do is fix small areas and lines, and let's say tolerance is 200 millimeters. And then we just start, and let's see what it does. If I fix that, it will remove those small areas, and same for here. It will remove this small, which is not interested in this model. So I will fix all, apply, okay. So it has deleted remove the small area, same as here. Okay, this is now good, but how do we know that it is good? Well, the finite element generating the mesh is one thing, but you can also put this load cases, the structure dead load here. With this, you can check the displacement if they are correct, if nothing is hanging like 1 meter to the wrong place, or the displacements are okay, then you can see if it's okay. But I will add these supports to this structure, and now we'll this. And now I can use these object layers new tool that I want to hide these access. So I can do this. And I want to hide stories also. Why did I want to hide them? Because I'm going to use this line support group, and it has this tool called line by selection. So I want to choose all of these bottom edges of walls, but in the same time it will choose this axis. So I want to hide them. Now it will only choose the bottom of this wall. And with this, just I managed to do all of these. All of the line support groups are now on top of the bottom edge of these walls. We can do same for point support groups. It has the select endpoints, and I want to select bottom points of these columns, like so. And now they're fine. And maybe a little showcase about this. If I want to change this wall into a column, we have this. When I go to a column, we have this convert button. So I will convert this wall into a column. You can see it here. And when I press the physical view, it looks the same. So when you export an IFC model, they could be columns, but if I want to choose them back to walls, I can just press convert. So you might have in your IFC file that all the walls are columns and not walls. So you can easily just convert them back. Okay. And maybe I want to convert these roof into covers. So I can just press cover and convert them. Yeah. Just move them a little bit. Like so. Oh. And there you have the supporting structures, and I will automatically detect them. And you can see these distribution lines for the cover. So this wall will take load from this area. There's the distribution lines there. Okay, but let's do a little bit more with this model. I will create also live loads and maybe fire accidental. Yeah. So the dead load is based on the density of the structure, so it calculates automatically. But I can also add some live loads, for example, surface load to the roof with this. Pick existing regions. If you have different or hard geometries, you can just pick existing region and it goes to the slab you want it. Okay. And now I can show you how to create automatically the load combinations. And in order to do that, we have to make load groups. Just a quick live load A, and this could be category A. And then last one is fire, and it type is accidental. Yeah. Now, in these load combinations, you can generate automatically. Let me see. I can create automatically the load combinations here by generate button. Okay. By this generate button, I will choose load groups, which make the which is included in the combinations, and here the combinations that this program will make. And just press OK, and there all the combinations I asked. There's also the accidental load. Okay. I have a question here. Okay. Yeah, here. I had a power outage, so I missed where he showed how to import IFC, how to do that. Well, you can just file open and edit and find the file type IFC and just press open. But we will send you the recording so you can check this afterwards. And you used point and line support groups, but not SPT and LPT. And I guess that is point support and line support. Well, the point support creates support only one direction, but if I want to take the vertical loads also, the X direction and the Y direction loads also, then I want to choose the support group. If you check the default settings, you can find the data here, and it has the X, Y, and Z directions here. But if you check just the support, it has only one. It has only one direction of support. So if you want in the other directions also, then you choose the support group. Okay, I will just do a smaller mesh that this will calculate faster. And maybe also one tool is if you don't want to open the settings menu, you can just press the size and it opens the correct part of the settings. So you don't have to find the correct place on the settings. You can just press here, say in this size, and automatically the element sizing settings will open. And talking about the settings, you can check the bar element parameters. There's only 2 nodes here, so I might want to add them to, let's say, 5. Yeah. And just to make sure that the mesh is now okay, I will generate it once more. Yeah, it's fine. This is only just that the calculation will go faster. And how to do the calculation? Well, you can choose this analysis tab and calculate, and here you can find that which kind of calculation you can do. If you have defined construction stages, you can activate this. And if you have a frame, you can activate imperfections and stability analysis. And there's also these dynamic analyses. But for now, I just use the load combinations. But we can check what the setup by load combinations is. So if I have any nonlinear or plastic calculations, I should have the X here. But in this case, I don't have anything related to this. So no second order analysis, no imperfections, no cracked section analysis, just nothing, just basic calculation. Where can we get the IFC file for this exercise? Will you send along with the recording? I will have to ask if I can send this IFC file. I don't think that there's anything secret about this. I will ask and we will send it if we can. In the finite element, when we click on prepare, the option is of region border. What region border do? Prepare. There's no. And the prepare button, if you have modeled the soil from this, let's say in the structure tab we have this soil. If you have modeled it as 3D objects, then you have to prepare it, as I understand, because it said there is no wall soil without mesh or invalid mesh. Yeah, I think this should be okay now. Thank you. What about seismic analysis? I'm not going to go into seismic analysis in this webinar, but you can do them. There was these different options for dynamic analysis. But in order to do that, you have to convert the loads into masses. But I don't have much load here. But I'm not going to go into that now. But how to know that this model is now okay? Well, you can check the load combinations and, let's say, color palette. And now you can see that this has bigger load, so it will the displacements are bigger. And we can also show it in the deformed shape. So nothing is floating in the air, or everything is now okay since the displacement is so low. Let's see also how to apply moving loads. Well, it's not, let's say it's not in this webinar, but I will link you, I will show you I have let's say this, FEM-Design tutorials in English. There's 53 videos. You can check, you can find it in the YouTube, FEM-Design tutorials English. I'm sure that there are the moving loads also in here if you check, but I'm not going to show you in this webinar. And I mean, I don't know. I mean to say in setting calculation mesh prepared, there's option of region border. Let's see, prepare. Region border. I will answer you this after this webinar, so we don't waste time in this. Let's see. But should the IFC be from Revit structural? I mean, the elements should be defined as structural element in parent Revit. In my case, I have no experience in Revit, so I don't know, but I think they should be defined as correct structural elements, so they will automatically be correct in this FEM-Design also. Will I make demonstration with adding temperature load on steel and geometrical imperfection? Not in this webinar, I'm afraid. It's a bigger. It's more complicated. I don't have the time right here. I just want to show you how to get started, and these are the more technical agendas you are interested. But I can maybe after this webinar I can ask, do you have some tutorial for really beginners? These FEM-Design tutorials English, 53 videos. It goes from the beginning. There's a video, small videos you can check. I think this could be good for beginners. Yeah, if Revit elements are defined as structural, they will be received as such. Yeah, okay, but let's go into the agenda. What I wanted to show you, this maximum of load combinations, and I want to check which combination creates the maximum of compression. And I can check the results here. Few, just few, and it says the number and the load case number 1. So if there would be any other load case that gives the bigger value, it says that load combination X or Y or 2 or 3. Yeah, I guess this is for the IFC file. We can return to this also. Some small designing steel design or RC design if we have the time, but I will show you the other method now. Let's open just what I miss in this tutorial when I have inclined bar and want to add perpendicular line load to the bar. You can do this. Let me just quickly 5 and 1. Now it's in the inclined. It's just some load, and when you are adding the load, you can see this is now like this, but then you have the direction parallel of the local axis. Yeah, this should be different. Let's see. But you can check you can change the coordination, global or the coordinate. So this should help you in that matter. But let's just quickly introduce the external reference. So file, external reference, and you just check the file path. And here's the DVG, and where you want to place it here. Show X direction and Y direction, and then you can choose which layers you want to import. Let's say I want to do all. And there you have the IFC file and now I can create walls, let's say plain wall, placement above, and you can choose the edge connections here. They are now hinged, and you can check the thickness here and the material. We have the automatic creep factor calculator based on the age of concrete, relative humidity, and the cross section. Yeah, these are okay. But now you can easily just model your structure based on the AutoCAD reference. Let's say here, just some quickly do something, and just plates here. It can be like this. Just a few holes. Let's say there's a staircase and elevator here. Yeah. And now I can define the stories myself. So it could be 4 stories here, and they are all 3 meters high. And this is the size of the building, and this is necessary for the wind load macro. Okay. So now I will also hide these. Yep. Now I can create the stories. Just the supports and the point support groups. Yeah. And with this copy story feature, I can now, if this story is the same as the above stories, I can do the copy story feature and just check the source and where I want to copy it. You can also copy the loads if you have made them. So now just copy it, and now I have 4-story high building, easily made. But if I want to use the automatic wind load and snow load generators, I have to add these covers to all of these surfaces which are taking the wind load and the snow load. Let's say in the roof we also have, so like this. And then just configure these climate load panels you can check you just give the positive direction to the wall or the cover. But here I wanted to use this draw panel. I will show you in the roof this draw panel. So I can just draw this panel to the roof and it will automatically take into consideration all these other covers. But for some reason this external wall draw panel is not working in this current version. So some magic trick just happened and now I have this older version of this model which I was able to make this. So I will show you how to create the wind loads. Is there any search command bar for quick access of tools? Let's see. There are you can see the settings, environment, and commands, and here you can choose your own commands. This has the smaller. You can define these as you like. For example, for loads. Yep. Do you always add edge connections on top of the wall? Well, it gives you now. If I check the edge connection loads, it will show me the top and bottom edge of each wall. So it's not necessary, but I like to see it. I like to see the bottom and top reactions. So okay, how to create the wind loads? I will delete the existing ones. Here we have the wind load, and there's the generic building, and just press this button and set the wind speed, and the building height is automatically gathered from the story function. In this case, it's 9 meters. Just press OK, and now it has created wind in the four directions: x positive, x minus, y plus, and y minus. And we have this color schema, and I have added this surface loss intensity so I can see which color is which intensity. It will help. You can do also another useful things with the modeling with this color schema. Let's say beam, truss, and column. You can put this cross section, and you can see all the cross sections in different colors. These are useful for modeling. And same for the snow load generation. How do you delete the analysis? If you do some modification to structures, it will automatically be deleted, but I don't know if you can just delete an analysis. I don't think it's necessary. But what I was showing is this snow load, and here you have special cases. If you have connected roof, attic wall, tall building, or snow fence or snow overhang, you can take them into consideration also. But in this basic model, I just want to generate the snow load, and in this button you can see the map representing the characteristic snow load on the ground, and this is Finland's map. So it could be like that, and I don't want to create any drifted loads. So yeah, there's that also. What's the difference between regular building and generic building? Well, I'm glad that you asked. This is now the generic building, and it creates the zones, which has in the Eurocode the windward and the leeward zones. You can see it here. But if I were to do the another one, the regular building, it will create line loads to all of these slabs. Let's say if we can do that. Yeah, there you can see. Now it just creates the loads as a line load, not surface load. And that's the difference between these two. When you send the link, video link, can I download and save on my PC? I'm not sure because it goes to the go to stage platform. So I'm not sure. You have to try. The FEM-21 version under 3D structure model that I have doesn't have the same interface. I don't have same interface. Hey, yeah, that could be this in the top right corner. There's the user interface. It could be compact. So you don't have all the buttons that I have. So change the user interface to full and you can see all the buttons here. Yeah, that could be it. When we are using the regular building, don't we need to cover regular building? No, you don't need a cover then. It will detect the slabs or the horizontal, vertical structures and automatically generate the wind on them. So you don't need the climate load panel or the cover. If the building is rounded with many buildings, how to calculate the wind load? You can just don't add this climate load panel to one side. If there's a building, existing building, just don't add this external wall there and it won't create wind on that side. We have some issues with deleting. It doesn't. If you have any problems with this program, I just suggest you go to this. You can find it in our web software site, StruSoft, and then you contact support, and you can send this is in Finnish. You can submit a ticket so we can answer and take a more detailed look into your matter. But maybe I just show you in the existing model view measuring, designing jobs. So for example, if I want to design this steel bar, it is easily done with just go to steel design, check the utilization, and you can check the detailed result from it if you have the correct result visible. So here you can see how it is calculated, and the summary is here. Yeah, same for the fire design. Yeah. In this case, I have already added, sorry, wrong result. Yeah, in this case, I have already added fire protection to this. So there's the board, gypsum 11 millimeters thick. So the utilization is under 100%. I can also try to remove it. Yeah, now it's 400%. And if I add the fire protection, let's say that, and auto design, and now it's only 79. Yeah. Okay, this is a short introduction. I cannot show you everything. This short amount of time, this 1 hour. I just wanted to show you how to get started in this program. And if you want to try yourself this FEMDesign, you want a trial or book a demo, you can do it with going to our website, strusoft.com, and check the FEMDesign, and here we have the get a free trial. You can book a demo, ask for a trial license, or if you are a student, you can get a free license here. Let's see, what temperature does it consider for fire design? You can choose it. Let's see, just a small. It says here the duration of fire and the temperature curve, standard external hydrocarbon, and the exposure, you can change it here. For example, if you have a I-beam or something like that. Okay. When we have a further session, I think we can book it tomorrow if you want. I will be in contact you maybe. And it was a great webinar, and I look forward to watch more webinars with you. Yeah, this has been the introduction, and I show you the IFC import and the DVG import and some small designing and some small things about the user interface. So I would like to, do you have tutorials in book form? No. Or PDF files? I think just a minute. Oof. Training videos. Hey, I will send you the link to the basic course package PDF file. I think we have that in the wiki also. I couldn't find it now. Can we get a webinar there more? Focus on documentation. I forgot to show you the documentation, but we have 8 minutes now. So let's say you want to add this view to documentation. Okay, just press here, add view to documentation. And let's see, I want to add one designing report also. So let's see, there, add view to documentation. Yep, and we'll go to the documentation tab, and there's the picture I just created, and there's the steel design report in here also. Here you can see, and I can also create a title block. Let's see here, title block here and cover page. Now it's question marks, the project description, companies, it's question marks, but go settings, environment, I mean settings, drawing, title. Here you can put your own. Yeah, now you can see that it has been changed. This is just short, short, but you can find it more in this FEMDesign tutorials. I think there's the documentation in FEMDesign, the video 53, where I can find the tutorials. I try to send you the tutorials, but these video tutorials on the YouTube, FEMDesign tutorials English, just search them here. But company name isn't right. No, it's not right. But you can check the company name. But it has the letter A here. There, text. You can edit the text here with this description, this question mark. Let's say it's StruSoft Finland. Yeah, and now you can change that. And you can also change this company project description text. I have already made one my own. Let's say here, I have translated this to Finnish. Just a quick show. I think this is enough for now. I will answer you all the questions I didn't answer you now. So thanks for participating, and I hope to see you in the next one also. Okay, bye.